today in the lecture series of Basic of Database Management System, today we discuss the operations on the relational algebra. We have already discussed the unary operations like selection, projection. Today we have discussed about the binary operation in which we have need to find the relation between the different tables, or we can say that if the two tables are given to us and if we want to find the relation between these two tables, then this unary operation will not work. We need some operations that work with this unary operation like Cartesian product, natural joins, equijoins. We have discussed about these operations. So what is Cartesian product? This type of operation is helpful to merge column from two relations. Generally, a Cartesian product is never a meaningful operation when it's performed alone, because if we apply the Cartesian product on two tables that given to us, it just combine this first table with the second table, but will not get any output from that. So with Cartesian product, we need to apply certain operations also like selection and projection. So it combines two relations, that R1 and R2, without any condition. Just we need one attribute common between these two tables R1 and R2, then we are able to apply the Cartesian product. So the rule for applying the Cartesian product is that if we want to apply the Cartesian product on two tables, then we need at least one attribute common between table R1 and R2. On the basis of that, we can apply this Cartesian product. So we can say that if what was the degree of the table that will get as an output of the Cartesian product of two relations R1 and R2. So then the degree of R1 plus the degree of R2 is the degree of the output table that will get after applying the Cartesian product on two relations. So the degree is the total number of columns of R1 plus R2. We'll see that how we apply this Cartesian product on two tables. These two tables are given to us. This is the table 1. This is the table 1 and this is the table 2. If we want to apply the Cartesian product between these two tables, then the symbol that we use for applying the Cartesian product is table 1 cross table 2. So this Cartesian product is also called the cross product. We sometimes know this Cartesian product by the name cross product. So we'll use the symbol cross between this table 1 and table 2. How this operation works? After applying this Cartesian product on these two tables, we will get an output table in which we have contained the attributes of table 1 and table 2. That is registration number, then branch, then section, then name, and then registration number. So we have one attribute common between these two tables, table 1 and table 2, that is the registration number. So what this Cartesian product actually do? This Cartesian product multiply the row of table 1 with every row of table 2. So in output, what we'll get? We will multiply this row with this one and this row with this one. Then second row with this one and then second row with this one. So we can say that the every row of table 1 is we multiply with the every row of table 2. So in output, we will get 1, CSC, A, Bhanu and 2. Then again 1, CSC, A, Priya and 4. Then second row, that is 2, ECE, B, Bhanu, 2. Then 2, ECE, B, Priya, 4. In this way, we will multiply one row with second row and at the output we will get this. This is the Cartesian, this symbol implies the Cartesian 1, this R1 implies the table 1 and this R2 implies the table 2. So this is the output we get. We will multiply each row of table 1 with each row of table 2. So this is of first row, this is of second row of table 1, this is of third row of table 1 and this is row of fourth row of table 1. And this implies the first row of table 2, second row of table 2, first row of table 2, second row of table 2. So in this way, we will get just multiply every row of table 1 with the every row of table 2. So this is the output after the Cartesian product. As we say that for the Cartesian product, we can apply Cartesian product only when the two tables have at least one attribute common. So in the table 1, we have registration number, and in the table 2, we have again the registration number. So on the basis of this attribute, we have combining these two tables, that is table 1 and table 2. But we also say that this Cartesian product is not helpful for us until we cannot apply any other operation on this product. We will get this table, we will get this relation of combination of R1 and R2, but we will have not used because we are not finding any data from this. So we have need to apply at least selection operation or the projection operation on that, so that we will get the desired output, or we will get the data according to the user query. So definitely we say that this Cartesian product work when we have applying other operation with this Cartesian product. So we mostly use the selection operation with the Cartesian product. So this is very important operation for finding the relation between two tables, and this is very important operation in the DBMS in the relational algebra. Then we have talk about the join operations. Join, its Cartesian product is a type of join operation. So join operation is essentially a Cartesian product followed by selection criteria. We can say that as Cartesian product is not only work. We need to apply selection operations or projection operation on this Cartesian product, then it only work. So this Cartesian product is again a join operation in which we have apply followed by selection criteria. This is denoted by, Cartesian product is denoted by this. Then we have another operation that is natural join, that is denoted by this. So we have join operation, that is cross, and we are on the basis of different type of joins, we have different symbols for the different join operations. So we have mainly two type of join operation. One is the inner joins and one is the outer join. So we have different type of inner joins, that is theta join, eq join and natural join, and the outer join, that is left outer join, right outer join and full outer join. We will discuss these type of joins one by one. So first we have discussed about the inner join. In inner join, only those tuples that satisfy the matching criteria are included. All other rest are excluded. The only criteria, the only condition we have in the output, we will get only that tuples that satisfy the criteria, that satisfy the condition, while other tuples we have exclude from the output. So we will discuss this. The type of inner join is theta join. So where we apply the theta join, if we have two tables and if we want to join that table, but in two tables we have not any attribute in common, then in that case we are not able to apply the Cartesian product. In that case, we have applied the theta join. We will take one attribute and we will combine that attribute with the second attribute of the second table, with any attribute of the second table, but their domain of values are same. We need that their domain attributes are different, but the domain of their values need to be same. On that cases, we can apply the theta join if two attributes are not common. We will see example for the same. So theta join combines tuples from different relations that satisfy the theta condition. So theta is noted by the theta sign. That notation for this is R1 join R2 with theta. This theta implies theta join. This implies join, and we use theta with this join, then it becomes theta join. So R1 and R2 are the relations that having attributes A1, A2 and AN in R1 and some attributes B1, B2, Bn in R2, such that the attributes does not have anything in common. That R1 intersection R2 is phi, that is null. So in that case, we can use the comparison operator. Theta join can use all kinds of comparison operators like less than, greater than, equal to. So the example is that we have given a table that is student and we have another table that is subject. We see that in student relation and in subject relation, we have not any attribute in common. We have here SID, name and student, and in second table, we have the class and subject. No attribute in common, but we have to find the relation between these two tables. In that case, we are not able to apply the Cartesian product because there is no attribute in common. So in that case, we have applied the theta join because theta join is possible to combine those tables in which there is no attribute in common with the use of the comparison operators. So we will combine these two tables. So this is the output of combining the tables of student and this subject. So how we combine? We can say that we have combining the attribute std of student table, this attribute, with the class attribute of the subject. That is, class attribute of the subject is this. We see that the domain is same. So we can say that if two attributes are not common, but we are combining those attributes that have same domain of values. So these have same domains of values. Then we join these two tables, student and subject, on the basis of the student attribute of the student table and class attribute of the subject table. So we will apply here the theta join on the table student and subject on the basis of these two attributes. And after applying these two attributes, we will get this. So we will see that we have applying the equal operator here. We will apply the equal operator here. So where the value of student std is equal to the subject s class, we will get only those tuples as an output. So we will see here that if we join this table with this, with this, with this, and with this, then again with this, with this, with this, and with this. So we will get at 8 column after joining this table with this table. But we want that only that tuples where the student.std is equal to the subject.class. So we'll see here that this is equal to this, this is equal to this, this is equal to this. So this is equal to this. So when we join these two tables, we will get actually 8 tuples. We will get 8 tuples, but from these 8 tuples in output, we will get only 4 tuples by, because we want that we will get only those values that is where the student.subject is equal to student.std is equal to subject.class. Instead of this equal to, we can also use less than, we can also use greater than, we can also use less than equal to, we can also use greater than equal to, we can also use the not equal to. We can use any comparison operator with the theta join, and according to that condition only we will get the output. So this is the theta join, that is a type of the inner join, in which we will get only that condition, in which we get only those tuples that satisfy the condition, all rest are excluded from the output. Then second type of inner join is equijoin. The example we have seen earlier of the theta join is actually the example of the equijoin. If in equijoin we can use only the equivalence condition, that is only the equal to symbol, then we can say that that is the equal join. So this theta join operation is an example of equijoin also, is an example of theta join also. In theta join we can use any comparison operator, that is less than, equal to, greater than, equal to, not equal to. But in equijoin we can only use equal to operator. We cannot, in equijoin we cannot use any less than, greater than, or not equal to operation. So when a theta join uses only equivalence relation, then it becomes a equijoin. We'll see here that we have two relations, that is A and B, and we have joining this, we have applied the equijoin here. Then we can say that where the column 2 of relation A is equal to the column 2 of relation B, we will get that output. And we will see here that the column 1 of relation A and column 2 of relation B are equal. Then we will get this output according to the given condition. So the previous example is also an example of equijoin and theta join also, and this example is also an example of equijoin also. If we use less than condition here, then it will become only the example of the theta join. So we'll discuss about the theta join and equijoin. Now we have discussed about the natural joins. So we can say that the Cartesian product not only works alone. If we are applying any Cartesian product on any two relations that are R1 and R2, then it's not only work. We have need to apply the selection operation on that, then only the Cartesian product work. So we can say that whatever the process done by the Cartesian product in 2 steps, that natural join, that work done in only in 1 step. It's automatically give us the answer by equating the attribute that common in both the relation. So the Cartesian product that done in 2 steps, then natural join will done that same work in only 1 step. So natural join does not use any comparison operator. It does not concate the way Cartesian product does, because we cannot say that we have only multiplied the tables and then we have applied the selection product. Then we can perform a natural join only if at least one common attribute that exists between two relations, then we can apply only the natural join. And the domain of that values of that attribute is also need to be same. then in that case we can only apply the natural join. So the attribute must have the same name and domain then in two tables, then only we are able to apply the natural join. In Cartesian product, it is possible that we have not two attributes are common. For example, we see that but their domains are same, then in that case we are able to apply the theta join. So natural join is only applied when we have two attributes, one attribute is common between two different tables and they have same domain. So natural join act on those matching attributes where the values of attribute in both the relation are same. First we have applied the Cartesian product, we will see in the PPT that first we have applied the Cartesian product in two table, then we have applied the selection operation. But it's automatically select where the value of attribute 1 in table 1 is equal to the attribute 1 in table 2. It's automatically give only those tuples where the values of that attribute is common in both the tables 1 and 2. So we will see this with the example. Here the two tables are given to us, that is the courses and HOD. In these two tables, we have one attribute is common, that is the department. On the basis of this attribute, that is department, we apply the natural join on these two tables, that is the courses and HOD. So what was the output we get? We will get this output. First, we will apply the Cartesian product here. We can say that after applying the Cartesian product, what was the table we get? First, we have CID, then course, then department of table 2, then head. This table we will get after applying the Cartesian product, and we will get values, that is CS01, database, CS, and LX. Then CS01, database, CS, ME, Maya. Then we have CS01, DB, CS, EE, Mira. In the same way, we have applied for the second tuple of the relation 1, that is ME01, mechanics, ME, CS, LX. Then same, and we will get here ME, Maya. Then we will same, and we will get here electrical and Mira. In the same way, we have three different rows, three different tuples in this table. So after applying the Cartesian product, we will get this table as an output. But we see that this output table we have no use until we have not applying the selection operation. Then we can apply the selection operation on the basis of this attribute where the value of this department of table 1 is equal to the department of table 2, or we can apply the relation less than greater than if we have the numerical values. But this natural join automatically done this work in one step. So we will get only those tuples where the value of the department of table 1 is equal to the department of table 2. We will see here. And it will automatically removes the duplicate column also in the natural join. So instead of 5 columns, we will get only 4 columns, because we will only select those tuples where the value of the department of table 1 is equal to the value of the department 2. We will get only select those tables. So instead of making the duplicacy in the columns, we will automatically remove this table and we will get this table as a final output. So this is the natural join where we automatically apply the selection operation of the Cartesian product in one step. We first combine the table and then we apply the selection operation, and we'll get automatically the result in only one step. So this is the benefit of applying the natural join over the Cartesian product. We have different type of joins. We will discuss these different type of joins one by one. So this will come under the outer join. We will see that in inner join we will get only those tuples in the output table that satisfy the condition that we have applying on the query. But in outer join we will get those tuples that satisfy the condition, but we will also get those tuples that do not match the criteria. We will see how we will get that tuple that do not match the criteria. So in that we have three types of outer joins, that is left outer join, right outer join, and full outer join. Sometimes we also need that type of tuples that does not satisfy our condition. For example, in some cases, we want that in the fraud cases, in the fraud card cases, in the fraud or detection of the cards, we will sometime we need the data that not useful for us, that not meet our criteria. So in that cases, we need some information. We need that tuples that does not match the condition of us. So here we have three types of outer join, that is left outer join. In left outer join, all the tuples from the left relation are included in the resultant relation. If there are tuples in R without any matching tuple in the right relation S, then the S attribute of the resulting relation are made null. We can say that this is two tables, that is left and right. So in this, we consider this table as a R, this table as a S. So after applying the natural join, we will get this table as an output, that is 100 and 100. We will get only those attributes if we apply the natural join here. If we apply the natural join on R and S, we will get the output after applying the natural join. We will get only these tuples, that is 1 and 2. We will not get this tuple. But if we are applying the left outer join, then we will get, after applying the left outer join, we will get this tuple 1 and 2. But we also get that tuple that will left into the table R. So we will include that database, we will include that electronics, but we will left this table that will not include into the output table. So we will add this, we will include this attribute, this tuple in the output relation also. So this is left outer join, in which if two tables R and S given to us, so after applying the join, we will get an output and we will include that tuples also from the table R that will not include the output table. So in this, we include all that tuples of first table that does not match the criteria, and we will put the value for that as null here. In the right outer join, in the left outer join, we include the tuples that does not meet the criteria of table 1. In right outer join, we will include the tuple that does not match the criteria of table 2. So we'll see that we will include 100 and we will include 102. And here in this case, we will use this table 100 and we will use this Maya also, and we will left this tuple. So we will include this tuple into the relation in this table of the right outer join. In this right outer join, we will also add that tuple into the output relation that does not match the criteria of the table 2. In left outer join, we will add the tuple that not include the matching criteria of table 1, but in right outer join, we will include the tuple that does not match the criteria of table 2. We also include that tuples into the relation, into the output relation, of course. And we will use, for left outer join, we will use the symbol join, natural join, and with the left sign. For right outer join, we will use this symbol and open from the right. In full outer join, we will include all the tuples that does not match the criteria of table 1 and of table 2. If we apply on these two relation, course and HOD, if we apply the join, we will get this and this. Then we will add the tuple of the left table, that is table 1, and we also add the tuple that does not match the criteria in the of the table 2. So we will, in full outer join, we will include all the tuples that match the criteria or that does not match the criteria. So in the next lecture, we have discussed these queries. We will discuss all the operations of the relational algebra and how we apply this relational algebra in the SQL. We see these queries in the terms of the SQL, that how we apply this query in the SQL or how we implement this query in the SQL and how we get the output. Thank you.